Hi, in this video, let's look at what is specific latent heat. Now, let's take a substance which is, let's say, a solid substance as shown by this square here. And we know that all substances are made up of multiple molecules. So, let's say there are a lot of molecules inside. And as we begin heating this, as energy is supplied to that and it's getting heated up, there are few things that happen. Let's see one by one what happens to the molecules in the solid. One is as the heat increases in the solid, the potential energy, let's plot all of them here. The potential energy increases because the molecules are moved away from each other. As let's focus on two molecules, for example, let's take these two. And as they are moved away from each other, there's a lot of potential energy that builds up, and that energy is supplied by this heat externally. And or rather the external energy. Then the kinetic energy also goes up as the molecules start moving faster. And we know that kinetic energy increase is what contributes to the increase in temperature, not the potential energy. So temperature also goes up. This is what happens initially. And if we have a plot of time versus temperature here, once we start, we see that the temperature keeps increasing, right? As with the passage of time. And after some time, what happens? There is a point where we know that let's take this as ice. After some time, the molecules are so far away that ice becomes water, right? Ice becomes water. So there is a point when these two molecules that we are focusing on become so far away that it changes phase from solid to liquid. Changes phase from solid to liquid. At this point, when they are moved so further away from each other, all the energy is utilized in separating, moving them away. Initially, kinetic energy keeps increasing, temperature keeps increasing, potential energy increases, but there is at this point where it exactly becomes the composition turns from solid to liquid, that is, the molecules are moved so far away that it exactly turns into liquid. At that state, all energy that is supplied, energy is still being supplied, but all the energy that is supplied is utilized in breaking them away or converting them from solid to liquid. So what happens is kinetic energy doesn't change, which means the temperature doesn't change. But still energy is being supplied and the substance is being converted from solid to liquid. So this phase where it's being converted from solid to liquid and the temperature doesn't change, this is called the state of phase change, or we'll call it as phase change. Phase change. So this is from solid to liquid. And the similar thing happens when water becomes vapor, and after it becomes water, again the cycle goes on like this. The temperature increases when you heat up water. There is a phase when the molecules are so far away that it becomes vapor, and when it becomes liquid becomes vapor, the temperature doesn't change again during the phase change. So this two states we have taken as example of water, and we can see that why temperature doesn't change during the phase change. So then what is specific latent heat's definition? The definition of specific latent heat is the amount of energy that is needed to transform 1 kg of solid to liquid, or in this case 1 kg of liquid to vapor. This is called specific latent heat. And in the case of solid to liquid, it is called specific latent heat of fusion. And in the case of liquid to vapor, it's called specific latent heat of vaporization. Vaporization. So the amount of energy taken, let's say Q, to transfer the mass can be 1 kg of the substance to the next state is called specific latent heat. So if it's solid to liquid, it's specific latent heat of fusion. If it's liquid to vapor, it's specific latent heat of vaporization. And as you can see from this formula, the units will be, the numerator is joule The mass is in denominator. So joule kg power minus 1. This is the unit of specific latent heat. Thank you.